Welcome, this is section 11.6, and in this section we will be optimizing the problems. What does that mean? What we do here is we look for relationship among the variables, we construct a mathematical model, and then we try to find the maximum or minimum of the function in that interval. So here we only have to deal with the first derivative, which is finding the critical values of the function, because keep in mind maximum, absolute maximum or absolute minimum are only given by critical values, and that's only our first derivative. So let's go ahead and take a look at the first problem here. It says find the dimensions. Let me go ahead and scratch this off here so you don't see the answer. Find the dimensions of a rectangle with a perimeter of 120 feet that has maximum area. Okay, so let's go ahead and draw a rectangle first. And not a rectangle. Let me try one more time. Very good. So that's a rectangle. I'm just going to say, let's say this is the x and this is the y, the length and the width. And what they're asking me to do is they're asking me to maximize the area. But the hint that they gave me is only the perimeter. That's fine. Remember what my first step is. I have to find the relationship and then find the mathematical model. Or sometimes it's easy to find the mathematical model and then find the relationship. They're asking me for the area. Area of the rectangle is x times y. But they gave me the hint of the perimeter. This is the area. And my perimeter is 2x plus 2y. And they told me that the perimeter is 120 feet. So if I factor the 2 out, x plus y is 120. And my x plus y divided by 2 is 60. And here I can find the relationship. What I'm trying to do here is I'm trying to change y in terms of x. So from here, I can go ahead and say y is simply 60 minus x. Once I have this, I'm going to take this y and plug it in here. So my area, so my function that I'm trying to maximize is my area. So instead of writing a, I'm going to write it as a function, is x times y, and I have to maximize this one. That means I have to find the first derivative, but I cannot find with two variables. So I'm going to go ahead and change my y to 60 minus x. I did not find the derivative yet. So this is going to be 60x minus x squared. And now when I find the derivative, this is going to be 60 minus 2x. I'm trying to maximize this. So I have to find my critical values. That means I have to set this equal to 0. So when I set that equal to 0, I will have 60 minus, I'm going to move to this side. I have 60 minus 2x is equal to 0. 60 is equal to 2x, and my x is equal to 30. So once my x is equal to 30, I'm going to go ahead and plug it in here. My y is 60 minus 30. That means my y is also equal to 30. So my x and y is at 30s and 30s, and that's where I get the maximum area. Both of them are same size. That means it's going to be a square that would maximize the area. Okay, so your first step is to go ahead and find the mathematical model, then try to find the relationship, plug one into the other, find your first derivative, set it equal to 0, boom, you have your values. Let's try the next one. A commercial cherry grower estimates from past record that if 20 trees are planted per acre, then each tree will yield an average of 40 pounds of cherries per season. If for each additional tree planted per acre, up to 21 additional trees, the average yield per tree is reduced by 1 pound. How many trees should be planted per acre to obtain the maximum yield per acre? What's the maximum yield? All right, so this I highly recommend when you have problems like this. It's always good to read and reread as many times as you understand. So let's go ahead and use my artistic skills here, and let's say I have a tree. So each tree yields, how much does it yield? Each tree yields 40 pounds. So 40 pounds. This tree yields 40 pounds. If I have another tree, so all I'm going to do is copy this one, and I'm going to copy this. Did I copy it? I'm going to copy this, and I'm going to paste it here. So if I have two trees, I'm going to have two 40s. So 2 times 40. If I have another tree, I will have 3 times 40. If I have another tree, what am I trying to show you here? I'll have 4 times 40. If I have X trees, I will have X times 40. Does that make sense? So that's the concept here. So now let's go ahead and see what we are doing. So the yield, so the yield that I have, how do I spell yield? Y-I-E-L-D, yield is the number of trees times the number of pounds that the tree yields. So what they told me is for every tree extra that I plant, so let's say I have 20 trees right now, correct? Yeah, I have 20 trees here. So if I plant 21 trees, my yield from 40 is going to reduce to 39. If I plant 22 trees, my yield is going to, remember what they said, the average yield per tree reduces by 1 pound. So every time you add a tree, the yield reduces by 1 pound. So if I add 2 trees, it's going to be 40 minus 2, which is 38. If I add 3 trees, it's going to be 40 minus 3. My yield is going to be 40 minus 3. If I add 4 trees, it's going to be 40 minus 4. So if I add X trees, my yield is going to be 40 minus X. And that is your mathematical formula. So your yield is nothing but the number of trees times the number of pounds that they produce. But if I add X trees extra, my yield is going to be that many pounds less. So my function f of x is 20 plus x times 40 minus x. Go ahead and multiply. This is going to be 800 minus 20x plus 40x minus x squared. So this is going to be 800 plus 20x minus x squared. This is my function. I'm trying to find the maximum yield, so I know I have to find my first derivative to find my critical values. Derivative of 800 is 0. This is 20. This is minus 2x. When I set 20 minus 2x to 0, 20 is equal to 2x, and my x is equal to 10. So my critical values, I'm going to have the maximum yield when I plant 10 extra trees. How many trees am I planting? 20 plus x. That is 20 plus 10, which is 30 trees. I'm planting 30 trees. How much is my yield going to be? How many cherries will I have? I will have 40 minus x. So my yield is going to be 40 minus 10, which is going to be 30 pounds. 30 pounds of cherries is what I will have. So here what he's asking you is hey, how many trees should I plant extra even though I know for every tree I plant, I'm going to have 1 pound less. So again, step is to understand, the first step is to understand how to calculate your yield, which is going to be the number of trees times the number of pounds that you get from each tree. If you have 1 tree and you get 40 pounds, you have 2 trees, you're going to get 2 times 40. 3 trees, 3 times 40. So that's what you have. And then you will set up your equation, first derivative, set it equal to 0, get your critical numbers, plug them in. And again, this is going to be, and when I multiply this, I have to plant 30 trees, but what's my yield? My yield, Y-I-E-L-D, is going to be 20 plus 10 times 40 minus 10, which is 30 times 30, which is 900 pounds. So my yield is going to be 900 pounds if I plant 30 trees. All right, let's take a look at the next one. I'm going to come back to this one, but I want to do the last problem before I do the second last problem. The cost per hour for fuel to run a train is, okay, the cost is V squared over 30, where V is the speed of the train in miles per hour. Note that the cost goes up as the square of the speed, okay? Other costs include labor and $480 per hour. How fast should the train travel on 420-mile trip to minimize the cost of the trip? They're asking me how fast should the train travel to minimize, okay? Should the train, so what they're asking me here is the speed of the train. How fast should the train travel? Let's go ahead and see what we have. They're asking us to minimize the cost. Okay, so the cost, let me go ahead and plug it here. Again, V squared over 30 is the dollars, and I have 480 per hour extra. So the cost here is V squared per 30 plus 480 for every hour. Do I know the time? No. So the time here is T. Again, if it's 1 hour, it's going to be V squared over 30 plus 480. If it's 2 hours, it's going to be V squared plus 30 plus 480 times 2. So here, T here is your time in hours. It's not times, it's time. Time in hours. So that's how I calculate my time. That's how I calculate my cost per hour. Okay, so once I have this, and again, I do see that I have 2 different variables, V and T. That's not what I want. Now I want to change either T into a V or V into a T. But how do I know what I should change? What am I looking for? I'm looking for how fast. That means I'm looking for speed. My answer should be in terms of V. That means I have to change my T into V. But let's see. What is the speed? Speed is distance over time, right? Here, my V is nothing but 420. V is the velocity, and the distance here they gave me is 420 miles. So 420 divided by T. In the other words, if I cross multiply, I have VT is 420. So my T is 420 over V. So look what I did. First, I created a mathematical model for the cost. The cost is going to be V squared over 30. They told me that. The runs for V squared over $30 plus 480 per extra hour. So if it's 2 hours, it's going to be times 2, 3 hours times 3. We do have the mathematical model. Now I have to see a relationship between V and T. I know that the speed is distance over time, and my distance is 420, and my T is 420 over V. Once I have that, what I'm going to do is I'm going to go ahead and replace my T. So I'm going to change colors here. So my cost, let me go and move it up here. So my total cost is v squared over 30 plus 480 times t. But I found out, or I changed my t into 420 over v. 420, right? Yeah, 420 over v. And now look what I'm going to do. I'm going to go ahead and multiply v squared over 30 times 420 over v, right? And this as well, distribute, plus 480 times 420 over v. V cancel. What do I have? 30 goes into 14 times. I have 14v plus, I can't multiply this one, I have to plug it in, which is 480 times 420 is 201,600 over v. So that's my total cost. Total cost. And again, I'm trying to, that's exactly what I have. And I'm trying to minimize the cost. The moment I hear the word minimize, you know what I'm going to do? I'm going to find the derivative. So now I'm going to write this as a function vt. I'm using f of v because there's no x here. 14v plus 201,600v. And you know that I have to find the first derivative. And that, I'm going to rewrite the function. Again, this is not the derivative. I'm going to do it in the next step. I don't want you all to get confused. This is 14v plus 201,600v. The derivative of 14v is 14. And again, derivative of this is to the power 1. So 201,600 times -1 over v squared. So this is going to be 14 minus 201,600 over v squared. I'm trying to find the minimum value, so I'm going to set this equal to 0 to find the critical values here. And once I set that, my 14 is going to be 201,600 over v squared, cross multiply, v squared is equal to 201,600 divided by 14, and my v is going to be square root of 201,600 divided by 14. And this is, I don't know, I have to plug it into my calculator. 201,600 divided by 14, and this would give me 120. Keep in mind this is a v, which is the velocity. That means it is 120 miles per hour. And that is exactly what we got, 120 miles per hour. So the key here is to find your mathematical model first, then find the relation, find the first derivative, critical values, and bingo, you have your answer. And again, not every problem is going to be the same, so you have to get used to this process of finding the relationship. All right, now let's go ahead and do the last problem. These problems are, so here you have, let's go ahead and read the problem. Let's see, what kind of problems are these in your homework? Just give me 1 second here. Okay, so these problems are from problem 8. No, this is from problem 6. Yeah, no, not even 6, 7. Not even 7. Okay, starting from problem 9. So these are inventory control problems. So these type of problems are called inventory control problems. So one of the basic assumptions made in these problems is that the demand is always going to be uniform. Let's read the problem first. A manufacturer here of hospital supplies has a uniform annual demand. So uniform annual demand for 180K boxes of bandages. It costs $10 to store one box of bandages for 1 year and $160 to set up the plant for production. So what does this mean? You have a big factory, and every time you produce these boxes of bandages, you have to pay $160. Now you can decide to produce all 180K bandages once, or you can decide to produce them multiple times a year. But every time you produce or you run the production, you have to pay $160. That's the production fees or production costs that you're paying. Okay? So now what they're asking me is, how many times a year should the company produce boxes for bandages in order to minimize the total storage cost and setup cost? Again, what's my total cost here? I am paying for the storage and I'm paying for the production. So the total cost here, I'm just going to say TC, is storage cost plus production cost. Production cost. Now you can say, Miss, I'm just going to produce everything once, so my production cost is going to be low and I'll be done. But keep in mind, when your production cost is low, your storage cost is going to go up. But if you produce multiple times, your storage is going to go down, but your production is going to go up. So you have to find that sweet spot where you can have the balanced amount of storage and production, so your cost is going to be minimum. Now, having said that, how do I approach this problem? So let's just say you are producing, so you use your factory and produce Y times a year. Just going to say Y times. So my production cost, I'm just going to say PC, my production cost is going to be 10Y. Okay? And you are producing X boxes of bandages. I want you to pay attention here because this is the assumption that you do for all these inventory problems. If there are X number of bandages produced in each production, so if you produce once, you're going to have X. If you produce twice, you're going to have 2X. If you produce 3 times, you're going to have 3X. If you produce 4 times, you're going to have 4X. Okay? So that's the number of boxes that you're producing per each production run. Because this is a uniform, the demand is uniform, what you have to know is the average number in storage each day. The average number of storage in each day is X over 2. So let me write this down. This is very important. Average number in storage each day is going to be X over 2. That's what you have to assume because the demand is uniform. Okay, the average number in storage each day is X over 2. So the storage cost is going to be SC is going to be 10 times, oh, my production is not 10. It's going to be X over 2. Sorry, my production here is 160. I confused. My production is 1. If I produce Y times a year, my production cost is 160. This is going to be 160Y, not 10Y. I looked at the wrong numbers. Okay, so now that you know this, the total cost, your total cost is going to be 160Y plus 10 times X over 2 is 5X. And keep in mind, this is, you're trying to make this your minimum. So I'm going to name this as my function f of x. 160y plus 5x. This is going to be my production cost. This is going to be my storage cost. And keep in mind, you're assuming that the average number in storage each day is x over 2. Now, if you look closely, I do have this y here. I have to find a relationship so I can change my y into x. How do I do that? Okay, how many boxes I have to produce? 180K. So the boxes that I have to produce is 180K. So I can run the production just once and produce all 180 boxes. I can run the production twice and produce 90K and then have 180,000. I can produce 3 times. Let me just write this down. 1 times and I can produce 180K. I can run the production 2 times and produce 90K. I can produce 3 times and I can run the production 3 times and produce 60K. So you can see that I can run the production y times and produce X number of boxes, because the boxes times the production should give you the total amount of bandages that you have to produce. Now, once I know this, my Y is simply 180,000 divided by X. Now, all I have to do is take this and plug it into here. So my function f of x is equal to, these are going to be huge numbers, 160 times 180 divided by x plus 5x. And again, once I have my mathematical model, to find the minimum value, I have to find the first derivative, which is going to be 160, again, negative, times 180,000 over x squared plus derivative of 5x is 5. And keep in mind, what do? You set this whole thing equal to 0. So this is going to be negative 160 times 4 over x squared is equal to negative 5. The negative cancel each other, cross multiply. My x squared is equal to 160 times 180,123 divided by 5. And my x, how do I find x? You simply find the square root of this whole thing here. 160 times 180,123 divided by 5. And I don't know what that is on top of my head. 1800 divided by 5. I get 2,400. So the number of boxes that I produce per production run is 2,400. Now, what did they ask me? They said, how many times a year should the company produce the boxes? That means, how many times should I run this production? In the other words, they're asking me the value of y. Y is equal to, remember what y was? 180,000 divided by 2,400, which is 75. So I have to run my production 75 times and produce 2,400 boxes of bandages per year, so I can save on my storage cost and on my planned production run cost. All right, hope this helps. Again, if you have any confusion, please, like always, please make sure you go through every problem and every example in your textbook so you get that understanding, especially when it comes to inventory control problems. Trust me, I have to re-explain myself so I make sense. It just doesn't come naturally. So I have to go back and re-explain and see how can I explain so it makes sense to y'all. So please read the textbook, look at your PowerPoint presentations, work through those step-by-step problems as a PDF file in your Canvas, and then use this video as a resource. Hope this helps.